Okay, we're going for a quirky format for our presentation today. So it's somewhere between a talk and a panel, perhaps a tannel. I'm not sure that's a word, but we're going to go with it. So we very much think about the automation of orebody knowledge as being an end-to-end process from hardware through to the software components, and that's really the reason why we've chosen to tackle this way. So I'm joined by two absolute experts in their fields. Nigel, who will be talking about the hardware automation part of the equation, and then Brenton's going to be chipping in and talking much more around the automation of the insights and the analytics that come off the back. And my job is mostly just to cat herd, but I am going to set the scene first. Okay, so really what's the problem that we're looking to solve for here? It's this concept that actually there are a number of places across the find, define and mine process where we actually need geological information to make good decisions. And normally, quite often, we need to be making those decisions in a timely manner. That doesn't mean real time necessarily, but it means that if you're at the find stage and you're drilling, you might need to make choices within the hour about, do I drill this hole, do I stop? Is this the right program of drilling for me to be executing on, or can I pull it short? And then if you go all the way down to the mine stage, it's about what are the things that I can understand about my ore body that might start to impact my drill and blast planning, so that's getting much closer to truly real time, all the way through to perhaps impacts to the way the materials get stockpiled and processed. So how does this happen today? Still, frankly, there's a lot of observational logging by geoscientists, and frankly, sometimes there's nothing at all because the time doesn't allow it, and so people make a decision where they need a geology, but they do it without the geology. So I would say there, we talk a little bit around the risk around this. There's some risks here around skill gaps as we have less and less geoscientists, but there's also opportunity. Because in fact, there's a lot of sensor technology out there. There is a lot of AI approaches out there now that if we use them together, there's no reason that we can't be making these geological decisions in a much more effective way. We just need to be able to string the technology together to do that. If I talk about that stringing together, this is very much the way we tend to think about this, is that if you want to automate orebody knowledge, if you want to have this end-to-end process, then you need to be thinking about these 5 different things. You need to think about how you're going to deploy the sensors in the first place, around the collection of quality data, and also the rate of productivity that you need to actually be able to collect the data on every single hole that you're drilling, every single rock that you see, through to the things that you then need to control on the data side. This is very much around the quality of data and the transfer of data in a way that allows timeliness and allows quality. And then the bit that perhaps gets all the attention, the sexy bit that Brenton gets to talk about, which is the algorithms, but the brutal reality is that piece around the algorithms, the plumbing and the quality that comes before that are really the key enablers that allow the sexy things across the algorithms and the answer products. And the last bit's really important as well, is where we actually have to be able to deliver this back to the endpoint user in a way that they can then consume it and actually take action. So really all of these steps matter, and we need to think about all of them. So as I said, we're going to start by thinking about the sensor deployment piece. So Nigel, traditionally IMDEX's strength was to make sensors that were quite complicated, deployable by drillers. And that was really the way that we would look to get that timeliness and the quality. The reality is for a lot of our customers now, we're starting to see automation appearing on the mine site around drill rigs, and that's driving us to start thinking about, well, what do we have to do on the autonomy front to shift from great driller deployed data to great autonomous rock knowledge data. So maybe I'll let you take away.
Still that. Thanks for coming, everybody. I was just excited about being up here, and then Michelle offended me by saying the AI was the sexy part. As long as I've been around, the robots were the cool thing, and it's certainly an industry that's changing. For the last 15 to 20 years, we were talking about the struggles to get the autonomy out there and working reliably, and the change management, getting these robots working in and around people. And over the last 10 to 15 years, I've seen that change. We're not quite commoditised with robotic and automated systems, but the focus is coming now on the data and the AI. So maybe thinking about, I think we've missed a slide. That's it, that's the first one. Just having a look at my journey with autonomy and having a look at what's changed over the last 10 to 15 years. As I touched on before, when I started my career in autonomy, people were struggling. In early 2000s, there was first demonstrations of autonomous systems. And then as we got into 2010, 2012, we started to see several large mining companies trialling and battling with the autonomy to get it to run. Over that time, and looking at some of the figures on the slides there, we've seen the growth of these systems go from fledgling prototypes to almost production out-of-the-box systems. There's still on-site change management processes that need to happen and education, etc. But there's several large OEMs and Tier 2 OEMs producing systems now that run very well, essentially out of the box. So in the last 12 to 15 years, we've seen the volume of these autonomous systems grow substantially. So some of the numbers you're seeing there on the slides, the autonomous haul trucks with the early Fortescue and Rio trials in 10, 11, 12, about 350 trucks in the market, about 2015. Looking at the numbers now, globally we're up around 1,600 trucks. Those are a mixture of large OEMs, but also several small OEM-specific autonomy companies that are retrofitting. If we also take a moment to look at the drills, the drills in some aspects have been leading the trucks. The autonomous drills were maybe out a little earlier, and given the volumes of drills to trucks, the number of units out there now at the moment, which is around 625, 650, depending on who you ask, that's a huge amount. And drills have always been very central in that data gathering process. Next slide, please. Maybe having a look at what's driving this growth. Why are miners looking to adopt autonomy in their processes? So a lot of these things here you've probably heard before. As we get a drive towards more safety, we've heard nil on bench, no foot, no traffic, whatever it might be, taking operators out of that harm's way. Operators, mining equipment operators, miners, are definitely taking a safety first approach. We've also got, over the time, vast improvements in the efficiency of these systems. The first systems would run really well to 75, 80% of an operator. Certain systems out there now are either surpassing the average operator or on average are getting up to that expert operator level. We're not quite there yet. There's some work to go. But for the mining operators, that efficiency, that dependency that they have on these machines to work almost every day, almost all the time, as opposed to operators who are sometimes not as consistent as a machine, that's also a big piece of the puzzle. The other thing we want to talk about today and put probably a big focus on is this demand for real-time data. When I joined the autonomy industry way back when, everybody wanted to talk about hauling dirt. Nobody was too interested in the data. But as I said earlier, this change that's coming through now, autonomy gives us the ability with sensors and systems that are at the edge, which are required to do the autonomy work. They just happen to be great sensors to be able to gather data for the sexy AI and the predictive maintenance for whatever it happens to be. At IMDEX, our bag is geotechnical data, and the BlastDog product, which is our autonomous, semi-autonomous robot, is where we put all those things together to bring the data down the pipe. Last slide. Maybe just a quick couple of seconds on how IMDEX is leveraging these technologies to make the data journey as good as it can be. So we talked earlier last night, Brenton, about what Brenton wants best from the robot. It's not to look cool, it's not to draw attention, it is give me the data as quickly as possible and as cleanly as possible. Big part of that is the robot. It's the best part. Maybe not, maybe the probe's the best part. How are we leveraging the technology with the IMDEX product? The IMDEX BlastDog is a remote control unit at the moment, has capability to do autonomous and semi-autonomous operations in certain parts of the cycle. We use the remote control belly box to take the machine onto the bench and to move the machine from hole to hole. We've got a feature called Auto Align, which uses LiDAR technologies to detect the hole and to let the robot automatically put the probe over the hole for lowering down. We then operate what we call auto winch. may not sound like a big deal, but what's important is making sure you've got a very consistent and measured depth for the probe. The probe will then fire its sensors. We record that data along with the depth within the hole, and then we officially pass that data off to off-board. One of the important things the BlastDog does that some other systems doesn't do, we focus quite heavily on the onboard QA, QC process for the data. Tara talked about earlier the importance of cleanliness of the data. If we were to pass data onto the upstream processes that either has extraneous outliers or it's noisy, all these type of things just put more work onto the really smart people that want to just do quality data processing. So some of that happens on board the BlastDog. It's still a journey and we're still doing more and more, but that's kind of how we treat Brenton as our customer, is we do everything we can on the robot and then we upload that data. And then what happens?
Great, I'm glad you asked. Next slide. So we've talked a lot about trucks and hauling dirt. Now I'm going to talk about rocks, because rocks are really the most important thing, especially when you're a geologist. And when we're trying to characterise our geology, we're really trying to put rocks into groups, and we're trying to understand those groups as completely as we possibly can. And this workflow on the slide here is really kind of the current state of how that works. So what we do is we hit that rock with a bunch of different sensors. Some of those sensors might be on the rig or out on the bench like the BlastDog. Some of them might be in the core shed where you're processing the core coming out of diamond drills or RC drills. And some of it might be kind of in off-site laboratories. And so over the last sort of decade or more, what's been happening is we've been stacking more and more of these data sets onto the rocks, because we want to characterise them in a better way, which is, of course, the thing we should be doing. But sitting above those data sets is a relatively old world kind of way of doing things. So we have a database which is engulfing all this data, and we have a bunch of experts that are sort of hovering around that data, and they might be modelling it, they might be looking at rocks and recording what they see. And this process has been in place for a very, very long time. And what's happening at the moment is that people are starting to drown in the data, essentially. So data keeps coming thick and fast, and there's only so much that an expert can really deal with before it starts being not used fully or not used at all. So we've got the right idea. Data is good. We want to characterise our rocks really well, but the downstream processes need to update themselves to be in line with that. Next slide. So what we're seeing as, I guess, emerging in the market now is this extra layer, which we're kind of calling the OBK analytics layer, or orebody knowledge automation layer. It's a layer that goes in between sensors and the database, which is our point of truth, which is trying to turn that sensor data into something you can make a decision on. It's trying to classify that rock, it's trying to predict some behaviour of the rock, and it's often using lots of algorithms that are often called machine learning. Some of them may not be. The key thing is that we've moved past the point in our journey, in our orebody knowledge journey, where we can just keep stacking sensors on and sensors on and expecting to have a really good outcome from that. So what we're doing, at Datarock, is we're trying to really kind of build that OBK automation layer. And as Nigel was mentioning, one of the big things that kills our ability to add value with machine learning and other algorithmic development is the data either isn't there, it's incomplete, it may be really inconsistent, we suffer terribly from inconsistencies through time, or it may even be the wrong data, or it may be untrustworthy data. There's so many different things that can stop us doing a really good job. And what we're seeing now is with automation, we can actually streamline that data collection and make it really consistent, and algorithms love consistent data. So that's really, I guess, the state we're trying to get to. Next slide. So an example of that, it's always good to talk about real-world examples. Here is an example from an iron ore. In iron ore, what all the iron ore groups are trying to do is bring down their modelling range. They're trying to model more rapidly in a more near-live manner, and because it makes giant differences to the balance sheet. But to do that, you have to assimilate and understand a very large amount of data, and you need to do it quite rapidly. So here's a workflow that we've developed with a client where we're taking downhole data sets, very similar to what the BlastDog might create, and we're basically trying to characterise those iron ore domains really rapidly, within hours, so that modelers downstream can have that data straight away, rather than having just to sift through raw data and try and pull those things out manually, which is very time consuming. Along with that, we might be imaging the chips or the fragments of rock that come out of the drills. We can also analyse those visually using computer vision. build another set of algorithms that then either adds to that model accuracy or even predicts something else. And then you get the slow data sets, the things that go to laboratories that could take weeks to come back. This is essentially really important data, and we want to then feed that data set in weeks later into a final version of the model. So we're trying to give the modelers data really quickly and then give them a final data set which is the best it can possibly be, and trying to automate all of that so that our experts are really just really leveraging those answers at the end rather than having to be the engine that creates them, which can be really kind of slowing down our operations. Jumping into the chips a little bit deeper, at Datarock we do a lot of computer vision work, so imagery in particular is a bit of a data set type that's been left out of all the fun, so we're trying to improve that. And so turning something that looks like a raw image that we might look at as a geologist, turning that into numbers, creating domains, and doing all that stuff in an autonomous fashion can really add to the mix of modelling and speed. So, yeah, next slide. Cool. Over to you.
Back over to me. I must admit I didn't really think about the fact I was going to cause a sexy war by implying that analytics was sexier than robots, but on me. I just wanted to maybe round things out. First off, really want to make the point that I think the two of you did a really good job of talking to three really key value props that we think about a lot when we think about the automation of orebody knowledge. Representativity of data, and by that we mean actually the concept that you can be collecting the same data on every single hole you drill. And there's a piece here around productivity and the technology you pick that is really key to that. I think, you're talking about using photos, Brenton, as almost a ubiquitous source of data, I think is a great example of that. Of course, a lot of what we've done with BLASTDOG design and productivity is to meet the same end. And then timeliness, this key thing that you have to be able to deliver the data when people need it to get the answers, and quality. We can't talk about the importance of the quality of the data from the start to the end of the process enough. So I'm just going to finish by talking about BLASTDOG again, and there's a couple of reasons for that. The key one is because when it was conceived as an idea, that workflow that I showed you at the start, where you go from sensor all the way through to actionable insight, BLASTDOG was always created with the intent it would do that within one system. And the reason for that was because the outcomes it was looking to affect were blasting outcomes, i.e. the closest to real time. So perfect world version would be that you run the BLASTDOG behind the blasting rig. It provides you information on, for example, hardness or blastability within real time. That then gets fed in and causes a change in the loading of explosives, and potentially that's being done through autonomous deployment of those explosives. So that really led to a lot of choices. I will call out at this stage, as well as obviously we had a robotics partner in this journey, which was UFR. I can see Jeff sitting up the front here, so I want to make sure that we call them out. But we had to make a lot of choices around the way the system was designed, all the way through from what the robot did to actually the sensors that we had on our multi-sensor array so that we could keep up with the rate. And then the data plumbing that we had to create off the back so that the sexy people at the end could actually do the analytics. So, I think it's for us been a really interesting journey to bring that product to life. And it has required all of those pieces in concert to be able to deliver to our endpoint customers the value that we wanted, which is insights that they can do something about in real time. And that's, I think, about it from us.
Thank you.